Hi guys, today we continue the study of Chapter 1, the scientific method. First, let us complete the example about the application of the Kepler's law. Last time we determined the constant C to be equal to 1 year square over AU cube according to Earth's orbit, Earth's period and the average distance to the Sun. Here AU refers to the astronomical unit, defined as the distance between the Sun and the Earth. It is equal to 1.5 times 10 to 11 meters. The second question of this example is to find Jupiter's average distance to the Sun when Jupiter's period is given by 12 years. For Jupiter, the Kepler's law gives the ratio between the square of Jupiter's period and the cube of Jupiter's average distance to the Sun to be also equal 1. Substituting 12 years for Jupiter's period, we have Jupiter's average distance to the Sun equal to Jupiter's period to the power of 2/3 equal to 12 to the power of 2/3 equal to 5.2 AU. Section 7. Why Copernicus is right. Why the Sun is the center, why the Earth revolves around the Sun. Theoretically, this can be proved in terms of Kepler law. We don't need to detail on how to prove due to being complicated in math. Observationally, there are two direct evidences. One is the motion of moon and planets. Another is the apparent position of nearby star. Shifts related to the distant star background. That indicates the Earth is revolving around the Sun. Gravity is a fundamental force between two objects with masses. There are four fundamental forces in nature, which are the gravitational force, electromagnetic force, weak force, and strong force. Gravity was discovered by Isaac Newton 4 centuries ago. He further developed the law of gravity based on Kepler's law when he tried to explain and understand why the Earth revolves around the Sun, why the Moon revolves around the Earth, and why apples always fall to the ground. The law of gravity is suggested to be universal, applicable to everywhere in the universe. It's valid. Why the Earth is round? Because Earth's gravity squeezes, the Earth is round, not flat, without large bumps and big holes. Earth's gravity pulls a large bump down and fills big holes in. Mountains and ocean basins are only irregularities in small scales. There are two direct evidence for the Earth to be round. The first is the top part of a common ship in the sea to be seen first, and then the body of the boat. Second is the shadow of a lunar eclipse to be circle. But the Earth is not a perfect sphere because it spins. The spinning of the Earth causes the Earth to be slightly bulged at the equator and flattened at the poles. The diameter difference between equator and the poles is about 43 kilometers. Another effect of gravity is tide. What is tide? Tides are phenomena that ocean water rises and falls, usually a few to tens of meters. Tides are caused by the gravity of the moon and the sun. A coastal area experiences a high tide if it is in the front of the Earth, i.e. the port A, which is strongly pulled by the moon's gravity and thus moves toward the moon, or behind the Earth, i.e. the port B, which is weakly pulled by the moon's gravity and thus moves away from the moon. An area neither in the front nor behind experiences a low tide. Therefore, each day, a coastal area experiences 2 high tides and 2 low tides. There are 2 unusual tides. Tides occurred when the moon, the Earth, and the sun are aligned, are called high or low spring tides. Tides occur when the moon-Earth line is perpendicular to the Earth-Sun line, are called neap tides. The law of gravity also played an essential role in the discovery of Neptune. In Newton's area, only 6 planets were known. There are Mercury, Venus, Earth, Mars, Jupiter, and Saturn. In 1781, the 7th planet, called Uranus, was discovered. However, the theoretically predicted orbit of Uranus is not consistent with observations. This discrepancy between theory and observations implies the existence of an unknown object that pulls Uranus away. From the law of gravity, astronomers first predicted the position of the unknown body and then observed it, named as Neptune. So for Neptune, astronomers predicted first, then observed. The final section of this chapter is about the SI unit system. It is the International Unit System. This system chooses length, mass, time, and other forces, not included here, as fundamental quantities and defines their unit as meter for length, shortened by m, kilogram for mass, shortened by kg, and second for time, shortened by s. Why we should use the SI unit system? It is simple, because SI units, subdivisions, and multiples are in steps of 10, 100, 1000, etc. These steps are represented by prefixes such as pico as 10 to negative 12, nano as 10 to negative 9, micro as 10 to negative 6, million as 10 to negative 3, centi as 10 to negative 2, hectare as 10 to 2, kilo as 10 to 3, mega as 10 to 6, giga as 10 to 9, and tera as 10 to 12. For instances, nanometer means 10 to negative 9 meter. Kilogram means 10 to 3 gram. To convert units between the imperial system and the SI system, we use some conversion factors such as 1 foot equal 12 inches equal 30.5 centimeter. 1 mile equal 1.61 kilometer equal 5,280 feet. 1 inch equal 2.54 centimeter. 1 pound equal 0.454 kilogram. In general, converting units from left to right, we multiply the factors. Converting units from right to left, we divide the factors. Now, for some examples, the first example is to convert 878 meter to how many kilometer and how many miles. Dividing 878 meter by the factor 1000, we get 0.878 kilometer. Dividing 0.878 kilometer by the factor 1.61, we have 0.545 miles. Second example is to convert a height of 5 feet, 8 inches into how many meters, how many centimeters, and how many micrometers. First, multiplying 12 by 5, then plus 8, we have 68 inches for the height. Then multiplying 68 inches by the factor 2.54, we have the height as 172.72 centimeter. Dividing 172.72 centimeter by the factor 100, we have 1.7272 meter. Multiplying 10 to 6 to 1.7272 meter, we have 1.7272 times 10 to 6 micrometer. Because 1 meter equal 10 to 6 micrometer. So we use that factor to complete the unit conversion. The third example is to convert a car speed of 60 miles per hour to how many meter per second. First, we change it miles to meter. Then we change hour to second, then divide. So multiplying the factors 1.61 and 1000, we change 60 miles to 96,600 meter. Since 1 hour is equal to 3600 seconds, then 60 miles per hour can be changed to 966 divided by 36 after cancel 2 zeros. So the result is equal to